All right, so here we are. We're going to do the last of 5 questions for momentum that's preparing you for your test and quiz. And we decided to do the traditional arrow passes through the apple. And you can see we have a pretty small arrow, but that's okay for the apple in any case. So the arrow is going to be coming towards the apple, and it's going to goes through the apple, and we're going to have afterwards a pretty complicated situation. So beforehand, we have the arrow shooting towards the apple, and then it blashes through the apple, and the apple is cut into 2 chunks. One chunk heads off in one direction, and the other chunk is obviously unknown directions. So what we have here is afterwards this bottom chunk of the apple, which we don't know what it's doing. And so the question is, what's the mass of that chunk? How fast is it moving? And what direction is that chunk going after the arrow passes through? You'll notice that the arrow initially is going fast at 30 meters per second. And then after it goes through, it's slowed way down as it passed through the apple. Okay? And the momentum before it hits the apple here is going to be the exact same as the momentum as after the apple. And the first thing we're going to learn here is that it's okay to use units other than kilograms as long as you use the same unit the whole time for momentums. Okay, so we're going to go ahead and leave it in grams and meters per second. And so if we're going to look at the momentum before the collision, we can get that pretty safely by just saying that momentum is mass times velocity. And so we're going to go ahead and take 50 times 30, right? And so we get 1,500 grams meters per second. And we notice that the units here are slightly different. We see that this unit here is grams times meters divided by seconds, which is not the normal kilogram meters per second. But it's fine as long as we always use grams. And we are. We'll notice that our apple, we're going to use 150 grams for that. And in the subsequent problem, we're also going to be using grams. So we have 1,500. And so when we come to this problem, we know that after the collision, the momentum must be 1,500 gram meters per second. And I'm just going to say east here because we remember that it was going in that easterly direction. Okay? So the north-south is 0. Okay? The north-south is 0, but the east is 1,500. Okay? And now we're going to try to figure out this unknown chunk here. But in order to get the unknown chunk, we need to first make sure that we have all of the components for the other ones. Okay, and that's going to be our first thing. We can take a second and just look at the arrow. That's a pretty easy thing to do. Since the arrow is coming in, and we'll assume that the arrow didn't change mass, so it's 50 grams, means that we still have a momentum here of 500 going to the right of gram meters per second of the arrow's momentum. We need to attack the upper chunk of the apple. And so we'll go ahead and look at the momentum up here. We have 80 times 5, which is going to give us 400, right? So we have 400 along the asymptote here of gram meters per second. And what we really want to know are these coefficients. So the coefficient going to the right as well as the coefficient going up need to be solved. And we have 30 degrees. We know this is a right triangle. So this is a simple sine and cosine of 30 degrees times the 400. So on the vertical, we'll get 200 gram meters per second. And on the horizontal, 346 gram meters per second. Everybody take a second and verify that those numbers are right. It's okay. We're going to keep it at 3 sig figs. We won't worry about the rounding. Please notice that as you're going along, you're going to have slightly different numbers as you do this problem, and hopefully you're doing this problem, not just watching me do it. You might have slightly different numbers if you round slightly differently. Okay, and that's okay. But this 346 and this 200 are now what we're going to use. Please notice we will not be using the 400 anymore. Okay, that 400, we needed it in order to get the 200. We needed it in order to get the 346, but now that we have them, we're not going to use the 400 anymore. Okay, so a lot of times we get a little confused. We end up using that number again. Just don't. Okay. We're now ready to solve the problem where we have the information we need. And what we're going to do is we're going to think both in terms of east-west, and then we're also going to think in terms of north-south. We're going to solve those separately. And it's usually nice to do the easier one first, and it's certainly easy to do the north-south here. If you remember, the original momentum had no north-south. It was just all to the east. Okay? Which means that after the arrow passes through, we know that we have no north-south momentum. And since we have 200 going north, that means that we have to have 200 going south. Okay? No choice in the matter. We have to have 200 going south. So I'm going to go ahead and draw that in. This apple chunk has to have a 200 gram meters per second momentum going south. And that's clear so that the north and the south cancel to give us a 0. Okay? East-west is a little trickier. We know that we had 1500 going east beforehand, and that means we have to have 1500 east afterwards. We have no choice. It has to be 1500. Okay? We have 500. We have 346. Right? That's not enough. We need more because we have to be 1500 being east. So how much east do we need? We need more east so that we'll end up with 1500 going east. Like 654 maybe? Someone check my math if you would. 654. So that means we're going to have this also going east a lot. I'll put 654 gram meters per second is our momentum going east. The reason for that is that if we add up all of our east momentums after the arrow passes through, we have 346 east, we have 500 east, we have 654 east. And if we add all three of those together, we should get the total momentum east being exactly the same as our 1500 that we had while the arrow was on its way to the apple. When it was on its way to the apple, it had a momentum of 1500, and that means after it passes through the apple, we also still need to have 1500. And we do, because we have 654 plus 346 is 1000 plus 500 is 1500 to the east. Good? That was a lot of work. We still have some work to do because these are just the components. And so to get the overall momentum, we need to do a little Pythagorean theorem here. Okay, so grabbing a Pythagorean theorem and calculating that. $684 sounds good. So you have 684. These are not meters per second. Okay, we're being careful. These are gram meters per second. Be also nice to get this angle here with an arctangent of 654 over 200. That'd be good. 74 degrees, beautiful. That looks appropriate. And that would be east of south. Okay, 74 east of south. Okay. If you drew the diagram the other way, you could be getting 16 degrees, right? That's fine. And now we've done a lot of work. We need to make sure we've answered all the questions. Okay? So the questions asked, what was the mass? If we remember, our apple originally had a mass of 150 grams. And now we have one chunk at 80, means that this other chunk must be 70 grams, right? Nice. We also were asked for the direction that it's moving, and that's 74 degrees, so that's nice. But we were finally asked for the speed, okay? And since momentum is equal to mass times velocity, we say velocity is momentum divided by mass. And since our momentum is 684 gram meters per second, I'm going to divide by the 70 grams. right? The grams will cancel and I'll be left with just meters per second. So we get about 9.7. You might have a slightly different number depending where you rounded, but that's fine. We get about 9.7 meters per second at 74 degrees east of south, and it's 70 grams. Okay? So I think we went through it hopefully carefully enough. Anybody have an immediate question that you think would help other people watching the video? Yeah? Okay, beautiful. So the question was, why are we using momentums for doing the problem? And if we look back to the original question, it was all about velocities and grams. There was no momentum ever discussed, right? And the question itself was asking all about velocities and grams. No momentum was ever mentioned in the question. But there's no such thing as conservation of velocity. It doesn't exist in nature. Okay? So we don't have conservation of velocity, so we can't use velocities to do these problems. We do have conservation of momentum. That's the power of all of this. So in order to do the problem, the very first thing we have to do is change everything to momentums. Okay? And then we stay in momentums as we do the problem. And then we wait until the very last thing we do. The very, very last thing we do is then switch back to velocities. Okay? And not until then are we done. Okay? Good? Awesome. I hope this helped a little bit in preparing you for your quiz. And if not, come and see me at lunch. I'll be available at lunch. Good luck.